Hello everyone, my name is Andres, and in this video I will briefly walk you through my final project of diseño de sistemas con procesadores. And my project is about a low-cost 3D scanning system using an infrared distance sensor and stepper motors combined with point cloud processing in Matlab. So the goal of this system is to perform rotational scans of objects and reconstruct their 3D surface based on polar measurements. So let's begin by understanding how the system works. So at first we need to know like a context or the importance of the 3D scanners. And basically in recent years 3D scanning technology has become increasingly important in areas such as manufacturing, reverse engineering, quality control, and even digital art and medical imaging. So these systems allow us to capture the shape and the structure of physical objects with precision and convert them into digital 3D models that can be analyzed, modified, or if you know, like printed. However, most commercial 3D scanners are expensive or too complex for educational use. So that's why in this project I develop, or with my team, we develop a low-cost and custom-made 3D scanning system using steppers motors and infrared distance sensors and a Matlab to reconstruct the object shape. So let me show you how it works. But after showing you like the machine, we need to, or I want to explain you like definite state machine that we use with my team to implement like the code. So as you can see here, the systems operates based on a simple finite state machine. First, the rotation motor advances step by step. Every certain numbers of steps, a distance is measured using the IR sensor, and once the rotation completes 360 degrees, the vertical motor moves the sensor up by fixed amount, and the cycle repeats. So the process ends after a predefined numbers of layers. Okay, so let's see the like a hardware overview. As you can see in the video, the physical structure consists of two stepper motors. One controls the rotation of the object and the other raises the infrared sensor vertically after each full turn. Basically the sensor uses the GP2J0A21JK analog IR sensor, which reads distances from the object's surface as it rotates. So all the data is sent over serial to a PC for post-processing. Although visually the design looks raw, with lots of wire and some components not fully integrated, but it works mechanically as expected. So as you can see there, the motors are moving and the sensor is like scanning the distances of the object. Okay, now let's see like the software that controls the motors and make the processing of the points. So at first, the firmware was written in C++ from Arduino, and as you can see here, the main loop controls both motors and periodically reads the distance. So each reading is printed in a CSV format as theta, angle, and distance that are polar coordinates. So this format is important for the Matlab stage, where the data will be converted into Cartesian coordinates, as I said before. And now we are going to see the Matlab processing that we do. And yes, as you can see here on this, we have the instance data. We use Matlab to read the file and convert the polar coordinates into Cartesian coordinates. So this involves calculating x and g from angles and radius and keeping zeta from height. So after this, we then generate a 3D point cloud and attempt to mesh the surface using the function surf, and the results are pretty good considering the simplicity of the system. And as you can see here, um, you can see like the image of the glass in the graphic. So here's the point cloud of a scanned cup practically. Okay, so this was my final project. But after concluding my video, I want to say like a final comments. So although the ray tracing rendering was planned, it couldn't be implemented due to time limitation. However, the systems prove functional, especially on the mechanical side. And I think that the biggest challenges that we have we had were sensor noise, calibration, and data alignment. So finally, overall, this project was an excellent learning experience. I thank my professor Juan Carlos Giraldo for his guidance and my teammates for collaborating throughout the process. So thanks for watching and have a nice day. Have a nice day.